what is a RASP or in-app firewall? How is it different to a WAF, a web application firewall? What do they do and how do they all work? Well, you'll never guess, but that's exactly what we're going to talk about in this video. My name's Mackenzie and you're listening to Tool Time by Aikido Security. So today, as you've guessed, we're talking all about firewalls. Now, firewalls is a pretty broad term. There's lots of different types of firewalls and they can act in different ways. There's hardware firewalls, there's software firewalls, there's firewalls for your network, there's firewalls for your infrastructure, there's firewalls for your application. Today, we're focusing on firewalls for your application, and there's two main ones that you kind of need to be aware about. Web application firewalls and runtime application self-protection firewalls, otherwise known as in-app firewalls. To be honest, I hate all of the names because I think they're stupid, but it does explain a little bit about what it does. It's a firewall that's self-protecting your application inside of it. Let's start off by talking about RASP and WAFs and what do they do, because they actually have a common goal. So the main purpose of this type of firewall is to be able to monitor traffic coming into your application, anything making requests towards your databases, your backend, or your application, and block malicious requests. Now, the main things that's trying to stop are SQL injection, command injection, cross-site scripting. It's also probably going to be trying to stop things like malicious users. So if you have someone that's persistently trying to do malicious activities on your application, you want to be able to block them. Firewalls can help with this. It's also going to be really fundamental in trying to stop bot attacks, like DDoSing. And in this modern era, it's also important to be able to control or limit the amount of scraping that AI tools can actually do, these AI bots and scrapers that are out there. So this is both what a web application firewall and a RASP or in-app firewall are actually doing. How they do it is quite different. The core concept of how they're different is a little bit simple to explain. A web application firewall sits outside of your application. So it's monitoring requests that are coming in. So if you think about it, when you go to a website, you visit it on your browser. So this is just kind of a rendered way to be able to make requests to your actual application. So those requests can come through the command line or they can come through the browser. A web application firewall is going to sit outside of your application, monitor all of those requests, information coming through, try and identify if there's anything malicious in there via pattern recognition, and then block it. A RASP or in-app firewall sits inside your application, obviously, as the name would suggest. And this means that it actually monitors traffic from the inside. So instead of kind of looking at the requests coming in, it's actually looking at what your application is doing with requests and blocks it. So to understand this completely, I have to introduce you to a concept called sinks. So a sink is basically where a malicious command or just a command kind of ultimately ends up. So let's say that someone's gone onto your application and made an SQL injection attack, right? So they've put SQL code inside a user input field or made a GET request and it's come to it. A sink is when that text, because it is just text, ultimately gets turned into a function, right? So the code is flowing through your application, but at some point, there's a sink. At some point, it's executed. Now, in the case of the SQL example, there'd be a function that db.execute, and the text all of a sudden turns into malicious code within this function. That's the sink. So the fact that an in-app firewall is able to monitor all these requests as they come in and understand where the sinks are means it's going to understand how your application is actually going to monitor this. Now, this results in a couple of things. It results in way less false positives because it actually knows what is going to be harmful rather than just trying to identify something that fits a pattern, right? So this can actually create kind of a better user experience, but it's also going to be more accurate because it can rely on more than just general pattern recognition to be able to understand how this code is actually going to manipulate your application. So one's kind of looking at traffic as it's coming in. One's looking at how the traffic is going to manipulate your application. Another area where you can really understand kind of the key differences is how you could potentially block a malicious user, or let's say like an attack. How you would typically do that with a WAF is by blocking the IP, because this is really all the information that you have. You can take the IP of where a user is connecting in from, and you can block that. But we know that you can change your IP, right? just a simple VPN. So let's say I'm a malicious user. I get blocked from an application because I keep doing malicious things. I turn on my VPN or I change my VPN's location and I can get back onto the application. Not only that, if there's a lot of people using that same VPN IP address, then you've just blocked a whole bunch of people. A RASP can block people based on their user ID. So a user ID can be assigned when someone interacts with your application, for example, through a header. So you can actually block that user based on more than just their IP. So if I turn on my VPN, same example, I'm malicious, all of a sudden, I still can't access the application. So you can see how being inside the application gives us way more ability to be able to monitor traffic and block it. Now, this is kind of currently sounds like a little bit of a video kind of dissing on WAFs and saying that RASP is so much better, or in-app firewalls. We still haven't figured out what to call them. The reality is that they're both actually great at different things. The great thing about security is that often we don't need to pick one or the other. We can actually just have both and use both of them. So for example, a very common thing to do is to use a WAF, for instance, something like Cloudflare, that's really good at volumetric stuff, right? When you've got big DDoSes coming in, we need to block big traffic. Cloudflare is great for that. And then you can couple that with an in-app firewall inside your application that's going to deal with those more specific attack scenarios. Now, in each video, I like to recommend open source solutions for it because I think it's important to make sure that we address what's actually available for free. So there are open source versions of WAFs and RASP, both of them. Probably one of the most popular open source WAFs is something called Mod Security, and this is maintained by OWASP. And the best open source RASP or in-app firewall would be Zen by Aikido, which I do need to let you know I do work for Aikido. So maybe you want to do a Google search for something else if you don't trust me. Now that I've rattled on for ages about all of this stuff, let's just show you what one actually looks like. So if you're wanting to run Zen or install Zen, essentially you need to run it in your application. So setup is kind of slightly more consuming than setting up a WAF because you can do that on the outside. But with Zen, it's very, very straightforward. Right now, I have a vulnerable application that's various different things. And what I'm going to do is I'm just going to show you some commands and I'm going to turn off and on an in-app firewall to show you kind of basically what's happening. So you can see this. There'll be a link for this demo application in the description so you can actually see it. So what we're going to do is we're going to start off with the simplest example of SQL injection. And what we've got is, here's just an example. So this is something where we're adding a new pet. So I have a dog. His name is Freddy. And we can see here that this is successful, right? This is a response. Now, what we can do is let's copy this malicious thing. So what this is SQL injection. And basically, we're trying to insert a malicious pet name, right? Into here. So if we do this, we get the same notice, right? Success. Now, so far, this looks like a crappy demo. Don't worry. So the reason is that I've turned blocking off. What we can do is in the dashboard, I'm just showing you this dashboard so that we have something fancy to look at. We have here events. So we can see here that this here is my malicious payload. It's detected it. Now, I don't have blocking on. So it's let it through, but it has detected that this is here. And we can do this same thing in various different other cases. So let's try kind of a path traversal. Now, path traversal, we're trying to read a file that we shouldn't have. So we're trying to kind of get back to our passwords file, for example, right? So here, if we were to read just a normal file, so this is here in this path. So we're trying to read a file, and we can read this file because we put in the path. But there is also a path here that is malicious because it's trying to access our secret keys. So just to quickly explain it, this ... this means to go back a level. So we're trying to go back from our application layer to kind of our infrastructure layer, kind of, to access our secrets and this key. We can read this file and we can see our secret key here. So this isn't working. But if I go back to the Zen thing, it's detected this path traversal. So we can see that this is actually working. All right, now let's just do that same thing. I'm going to turn on blocking, and we're going to do the exact same process and see what happens. So let's go back to SQL injection. We're here going to do the same malicious SQL injection command here, trying to insert this malicious pet, and we do it, and we get a database error coming back. And we're going to try the same thing with the path traversal. Can we get to our file again? No, Zen has blocked this path traversal attack. So there you can kind of really see this working in action and how it works. Now there's some other things we can do here. So for example, if we open up our terminal, this command here is basically trying to access our site here, our demo thing, but we're being identified as a bot. So when we go through this, it's telling us that we're not allowed to do this resource because we've been identified as a bot. So, and this is to do with our header that we have. So there's lots of things and lots of ways that you can kind of see Zen working. Now, before we start to wrap up, there's one more feature that I do want to talk to you about. So Zen has an open source version that we talked about. It's for Python or Node or .NET or various other languages. You can find them all on GitHub and you can run it in your own application. There is also the paid version. The core difference is that you get more ability. You just get a fancy dashboard that comes along with it, essentially, right? But I want to use that fancy dashboard to kind of show some of the more hidden features that are a little bit harder to demo on my demo application. So the first one here is our users. So I talked about this at the start of how an in-app firewall can actually identify a user. So here what you can see is we have various different users that have been identified, and we can actually see information about how we can track our users. There is some additional code that you need to add in if you want to set up user blocking specifically. But why I want to show you this is that if I click on one of these users, let's click on Ryan, what we can see is that Ryan's actually visited our site from multiple different IP addresses. So if we wanted to, we've got 50 in here and when he was. So Ryan's obviously using a VPN or does a whole bunch of travel, a lot. And if we wanted to, we could actually block Ryan from visiting this, regardless of what kind of VPN he's actually using. And we can kind of identify this with all various different kind of users. This is something that a WAF wouldn't be able to do. And what's also cool about having a RASP or an in-app firewall is that you can actually kind of see metrics from AI usage. So you can see what models are kind of accessing your application, your website, and how much kind of traffic and calls they're actually doing. So you can see if you get a kind of a big spike, a lot of these models and how people use them can actually kind of act inadvertently as kind of a DDoS mechanism for attackers. So you can also block the usage, and it also will tell you how much AI usage has actually cost. So here, obviously, on our little demo application, we're only paying about $0.01 for Anthropic to have the privilege of accessing our site. But we can monitor this more accurately, so we actually know and we can make kind of judgments based on that. There's lots of different settings and things that we can do, but I think generally speaking, you kind of get the idea. Enough now just to kind of know what the differences are, to know if you need a WAF or a RASP. Joke's on you, you actually need both, and to kind of know what are the options out there. So that's all I had for you today. I hope you found this video useful. Please make sure you subscribe to the channel, like this video. It really helps us out, and I'll see you on the next one.